Okay, so I was going to go through the questions that you had asked about. So the first one says consider a population of 250 with a mean of 65 and a standard deviation of 22. Was the probability of obtaining a mean of 66 or less from a sample of 35. And the way that I try to approach these homework problems is to kind of look at the example and see if they're wanting you to use technology or not. And a good way to see that is in the view an example. So for this particular problem, it looks like you're going to be calculating it by hand, but it's good to see what they are wanting you to round to also. So the first thing you want to look at for this one is the population standard deviation known? And it is. So let's look at some of our variables here. We have a population of 250, so our population number is 250. And then the mean of the population is 65. And then the standard deviation population is 22. So I always try to go ahead and label everything that I have. So we want to know the probability of obtaining a sample mean of 66 or less when the sample size n is 35. So that is everything they have given us in this problem. So if you look at the example, when we know the population standard deviation, then we can calculate the standard error of the mean. So let's go ahead and calculate the standard error of the mean, which is the standard deviation divided by the square root of n. And see, when we have already labeled everything, up at the top, all we have to do is plug in. So we get 22 divided by the square root of 35. So if you put that in your calculator, you'll get a long decimal. So look at the example. And it looks like they don't. Let's go ahead and go to the next step, and then we may just need to not round if we have to multiply it by the population correction factor. So if the population size n is finite and n divided by n is greater than 5%, let's see if n divided by n, if it's greater than 5%. So if you do 35 divided by 250, it is 4.14 times 100 is 14%. So that is definitely greater than 5%. So what we have to do is we have to multiply the standard error of the mean by the population correction factor. So the square root of n minus n over n minus 1. Let me erase this little part and make it. So that would be 22 over the square root of 35 times 250 minus 35 over 250 minus 1. So what you need to do here is, if you want to simplify it a little bit before you put it in the calculator, you can, but you don't have to. I'm going to do that. So when I put this in the calculator, I do 22 divided by the square root of 35. And I'm going to times that number, which is a long decimal. Do not round yet. Now, when you get this, you're going to get 3.4554. And I believe if you look at the example, because rounding is important, or because you'll miss it, you round to they want you to round this to the second decimal place, so you would get 3.46. So the standard error of the mean is 3.46. Now we can do the z-score, and this is a good way, if you view an example, to have your formula pulled up for you. So to get your z-score, you always take the mean of the sample minus, the desired sample mean minus the mean of the sample means. And that kind of sounds a little weird, so divided by the standard error of the mean. So when you're plugging this in, the desired sample mean is what we're calculating. So our desired sample mean is 66, or less than or equal to 66. And then minus your mean given to you at the top, divided by the 3.46. So if you do 66 minus 65 divided by 3.46, you're going to get a decimal. So let's keep looking. So when they give you the mean in the problem, this is important. So if the sample size is greater than or equal to 30, which it is in our situation, then you can assume that the sampling distribution is normal. So the mean of the sample or of this population is going to be equal to the population mean. So we can use that number given to us. Now, you're just going to round to 2 decimal places. So the 0.289 would round up to 0.29. Now, you have to use your table. So what you have to do, we can take this off. You're looking for the positive value, so it's going to be your second table. So go to 0.2 and go across to 9, and 0.29 is 0.6141. So the probability that X is less than or equal to 66 is 0.6141. And let me make sure that I copy that right. I always like to double check. Okay, so there's a 61% probability that the mean is going to be, the sample mean is going to be less than or equal to 66. Okay, so let me know if you have any questions about how to get your z-score and use that, and any questions about rounding or anything that you might have.